In today's lecture, we will find out the centroid of composite sections. For finding the centroid of composite section, we must know the axis and know the concept of axis of symmetry. What does it means? Suppose we are having a simple geometry like circle, so we will have the centroid at its center, that is on axis of symmetry. Say this is x and y axis. Suppose we are having a rectangle or square, we are having two axes of symmetry like this, so centroid will be at this point. If it is a triangle like this, isosceles triangle, then there will be only one axis of symmetry, and that will be a y axis. We don't know about the x axis, so for y coordinate we have to calculate the things. As in previous lecture we have already shown you that if its height is h, then from base it will be at h by 3 above the base. If it is a say quarter circle or semicircle, then there is a axis of symmetry y, but in x it will be at 4r upon 3 pi. 4r upon 3 pi. From where it comes 4r upon 3 pi? For that we have to go we have to solve it by the method of integration, which we have discussed in the previous lecture. So these are the standard geometry. Triangle, for triangle it is b by 3, h by 3. For semicircle it is r comma 4r upon 3 pi if y is set at this point. If it will be at this point, it will be 0. Quarter circle, if axes are selected like this, it will be at 4r upon 3 pi and 4r upon 3 pi. For sector of a circle, it is 2r upon 3 alpha sine alpha and 0 if x is the axis of symmetry. For common line segment, these are the area segment. If you talk about the line segment, then inclined line like this, it will be at the midpoint of that line, means L by 2 cos theta. This will be the L by 2 cos theta, and this distance will be L by 2 sin theta. So L by 2 cos theta and L by 2 sin theta are the common line segment. For quarter circular line segment, it will be at 2r upon pi and 2r upon pi. For arc of a circle, if line segment is like the arc of a circle, then it will be r sin alpha upon alpha. Mind it, here alpha is the half the included angle. Total angle will be 2 alpha. So how can we solve the problems of composite geometry? What do you mean by composite geometry? Basically, composite geometry means, suppose we are having a geometry like this. So this is what we cannot say where will be the centroid of this. This is a semicircular part. Where will be the centroid of this part? So if it is h, it is height h, then we can say from here at h by 2 there will be an axis which will be the axis of symmetry. So it will lie at this on this axis, but how much will be the value of x, that we cannot say. We have to split this composite geometry into standard geometry. Say one is your rectangle and other is your semicircular part, which we have to remove from the diagram. Another type of composite geometry you can say like this. In this we can say that this is the axis of symmetry. Y will be the axis of symmetry. One is this rectangle or square and other is the triangle. So this plus this will provide you the axis of will provide you the composite geometry. The third case, if you talk about like this, in this case, suppose this semicircular part is removed, so the remaining area is like this. What is that? Say first is your rectangle plus second is your triangle minus third is your semicircular part. So for this problem we are taking some numerical data and then we'll solve it. Suppose we are having a diagram, we are having a composite geometry like this. This is x-axis and this is y-axis. There is an inclined line, there is a vertical line, and a semicircular part is removed from here. Take some numerical values. Say this is 100 mm, this is 150 mm. There is a diameter of 100 mm which is removed from the geometry, and this is also say 150 mm. So the remaining shaded area, for remaining shaded area we have to calculate the centroid. X and y axis are set like this. Say this is 0, now this is origin. Split this geometry into standard geometry. Suppose we are making a line like this. So this is the first geometry, say rectangle. Its centroid will be at G1. Second geometry is triangle. Its centroid will be here. Say this is G2. And this third geometry is G3. Centroid is at this point, G3. For calculating the centroid of composite geometry, make a table like this. Say serial number, geometry, another is geometry, and then area of that particular geometry. Say A, this is in this will be in mm square. Here the all the dimensions are in mm, so area comes out will be in the mm square. X bar will be in mm and y bar will also be in mm. So start with the first geometry. What is the first geometry? That is a rectangle. Rectangle A1, first area of that rectangle is your 100 into 150 plus 100, that is 250. So 100 into 250, that is 25000 mm square. X1, say X1 is the midpoint of this, means 250 by 2. 250 by 2, that is 125 mm. And Y1 is your 100 by 2, that is 50 mm. Second is your triangle. Second is your triangle. A2 is half into base is 250 into height. Height is 150 minus 100, that is 50. Height is 50. So this will be 6250 mm square. 6250 mm square. X2, the value of this x2, for triangle it is 1/3 of base from here, and from here it is 2/3 of base. Origin is at this point, so this will be 2/3 of base. 2 by 3 of base is 250. And y2 is, this is 100 plus 1/3 of base. 100 plus 1/3 of, sorry, base nahi, height, 1/3 of height, that is 50 by 3. So this is why third is your semicircle. For semicircle, area A3 will be half pi r square, that is pi into 50 square by 2, or you can say it will be 1250 pi. X3 will be, say this is 150 plus 100 by 2, that is 50. So from here it will be 200 mm. X3 is your 200. And Y3 is 4r upon 3 pi. 4r, r is 50, 4r upon 3 pi. So these are the different geometries. In this we have to take care that A3 comes with the negative sign. Here we have to subtract this third geometry because it is removed to get the required geometry. After that, for getting x bar, we will simply have to put a1 x1 plus a2 x2 minus a3 x3 upon a1 plus a2 minus a3, because third geometry is removed. So by putting these value in this equation, we will get the value of x bar as 123.75 mm. Similarly, for getting y3, we have to put a1 y1 plus a2 y2 minus a3 y3 upon a1 plus a2 minus a3. And by putting these values in the equation, we will get the value of y bar as 69.38 mm. So by using these methods, we can find out the centroid of different composite geometries. Thank you.